Hi, I'm Mariam, a product manager for Flutter. Today we're going to share 7 tools and techniques you can use right now to make your Flutter code more readable, scalable, and testable. I'm joined by Eric and John, who will help me demonstrate these techniques to build a checkout experience in our Dash Shop app, an exclusive online store for Dash gear, stuffies, keyboards, you name it.
These techniques will help you build your Flutter app with a scalable and maintainable app architecture so it can go the distance.
And we'll also share some tools that you can use to add features to your app and some cool ways that AI can use them to assist you.
All right, let's dive into the code. The first technique is all about building a great UI, designed using constraints and not fixed sizes. Flutter makes it possible for us to have the Dash store available on any device and any screen with a single codebase. But with ease comes responsibility, as a wise bird once told me. It's our job as developers to ensure the UI is visually responsive while keeping the code readable and error-free. Designing using constraints makes your widgets flexible and more reusable than if they were using fixed sizes. That way, you can easily reuse them for mobile, desktop, or the web. Essentially, that boils down to 3 steps: abstract, measure, and branch.
The UI currently uses Flutter's Flex layout with widgets like row, column, and flex to help make sure the widgets resize based on the size of the constraints. But when the screen gets too small to display everything or so large that there's wasted screen space, you need to swap out the layout with an entirely different one appropriate for the screen size. So the first step is to identify the UI widgets that need to change and abstract the underlying data they share. In this case, the cart screen layout needs to change based on the screen size. We'll pass the data it needs to render in via the constructor parameter. The widget shouldn't care about where the data comes from, just that it needs to display it. Next, let's measure the size of your display area. Use media query size of for the entire app window or layout builder for the localized constraints. Since this is a smaller widget that we want to reuse, we'll use layout builder. Finally, we can read the incoming constraints that layout builder gives us and return different widgets based on the available size. To learn more, check out the layout docs linked in the description.
If our UI layout is broken or the app freezes, we could fiddle with the height of the container, hot reload, fiddle with the height again, hot reload again, or we could save some time and skip all of the guesswork by using DevTools to provide visibility into the app, such as the exact constraints that the parent widget is enforcing. Our second technique is use DevTools. Keeping accessibility in mind, let's make the images and the text in the checkout cart bigger so that they are more visible.
Let's see. That should be pretty easy. I'll open up Anti-Gravity and enter a prompt with the widget I want to change. Okay, so Anti-Gravity made the change. Now I'll tell it to reload. And we hit a classic issue, the dreaded layout overflow error. To help us understand what's going on, let's use DevTools to see which widget is causing the error. The Flutter DevTools inspector highlights these errors so we can see which widget is causing the issue. This row widget, which is overflowing. We can dig into the details ourselves, or we can use the Dart and Flutter MCP server to help us fix the issue. The MCP server makes Flutter's developer tools available to AI assistants. To install it in Anti-Gravity, we'll open up the Agent panel and select MCP servers under the Additional Options drop-down menu and search for Dart. Once installed, Anti-Gravity displays the available tools. When we run our app, our agent can connect to it directly. And once it's connected, the agent can read the layout error message using the Get Runtime Errors tool. Layout errors contain a lot of details that Gemini is really good at understanding. The agent knows how to use the hot reload and Get Widget Tree tools to help make sure that it fixed the layout error.
Mixing business logic and UI within a widget creates massive, unreadable, deeply nested build methods. By separating your business logic from your UI, your widgets become easier to reuse, modify, and test. So technique 3 is building reusable widgets.
As mentioned before, a widget should receive all the configuration it needs to render as arguments. It shouldn't have to modify or format any data. Its only jobs are to render data and listen for user events. As a rule of thumb, if your widget is importing low-level libraries, making remote requests, or interacting with a database, it's probably not reusable. In the Dash Store app, when a user presses Purchase, the widget doesn't turn around and call the Payments API directly. So in order to keep the widget reusable and only focused on displaying the UI, that logic is deferred to a different object using a callback that is passed in as a parameter to the widget's constructor. When your widgets are reusable, you can leverage tools like Widget Previews. Widget Previews is a developer tool that complements Hot Reload, enabling you to experiment with UI variations and states without running the full application. Rather than running an app, navigating to a specific screen, and getting the app into a specific state just to test button styles, I can write some widget previews for that button and pass them in, enabling me to quickly iterate on designs. This is straightforward since our widgets were built to be reusable. And if you're building with AI assistants, the Flutter team has published a skill, Flutter Add Widget Previews, that gives instructions to your coding agents on how to build previews for your app's widget catalog.
This skill is published as part of Flutter's official skills repository on GitHub, and it provides instructions for agents that can be shared and repeated to reliably complete a task for you. We authored this skill by grounding it in our official documentation. This means that the skills are up to date and keeps our official docs as the source of truth. Each skill has a name and description that tell the agent what it should be used for and when to use it. The agent reads it in only when it's relevant to what you're trying to do. You can find skills published by the Dart and Flutter team on GitHub, so you can start using them for your own projects today.
But we didn't just write the skill and call it a day. We've rigorously validated it with our evals framework to ensure it consistently works across use cases. Our goal is to consistently deliver tools to developers that help you build better apps. And with AI's rapid innovation, we want to make sure that each skill, MCP tool, and model change is making your apps better. So we're looking for ways to be more data-driven. In fact, we're experimenting with evals in public, so the code is open source and you can check it out at github.com/flutter/evals.
So now you can see that we have a widget preview for our widget. Previews let you test widgets in their various states and see how they look when placed next to each other. And we can use our skill to create previews for all of our important widgets. So our widgets are looking good, but now we want to start using them in our app. And for that, we need to talk about app architecture.
Separation of concerns is one of the core fundamentals of software development. In app development, this generally manifests as a layered architecture. So the fourth technique is to bake a layer cake. We layer our apps using MVVM architecture. All MV something patterns have a similar layered architecture using 3 objects that are roughly equivalent from pattern to pattern: a UI layer, a logic layer, and a data layer. In MVVM, your UI is separated into views, which are your widgets, and your logic is in the view models. View models act as a gatekeeper between the UI and the data layer. This separation of logic and UI makes your code testable and more readable.
View models have 3 jobs: transforming app data into data that's ready to be rendered, telling the data layer when user interaction requires app data to be modified, and telling the UI when to rebuild. And for that, we use Change Notifier. In the Dash Store app, the cart view model provides configuration for the cart screen and has properties like cart items and subtotal, and methods called add to cart and on purchase. On purchase is the callback referenced earlier that we pass into the widget. When a user presses the purchase button, the view model handles the local state, things like toggling is loading and calling notify listeners, but it defers the data mutation logic to another layer of the proverbial cake, the data layer.
Which brings us to our next technique, using the repository pattern. The repository pattern centralizes and abstracts data access logic, and it does so using objects called repositories. A repository manages the data in the data layer. It's the interface between your app and external data like server, database, or plugin. Specifically in our case, it exposes raw data from services to the view model.
This pattern is used to establish a single source of truth per data source in your app, and should be the only object that can fetch from or write data to an external source. When application data logic is isolated in this way, it makes your entire codebase easier to test and scale. If you want to try out these architecture techniques in your own apps, use the official architecture skill published by the Flutter team to make your AI agent an expert.
The sixth technique is to design for all platforms. What happens to your data layer when you need to use native features like payments? Flutter uses Dart, but platforms like Android and iOS expose these features using Kotlin and Swift APIs. Thankfully, Flutter enables developers to leverage native device features and third-party APIs through its massive ecosystem of plugins and packages on pub.dev. The huge win for developers is that plugins enable us to write Dart code that works consistently across all platforms, and the implementation details are abstracted away as a package on pub.dev.
Traditionally, to find the right plugin for payments, I'd leave my IDE, open a browser, hunt down the right package on pub.dev, and read through the documentation. But did you know that your coding agent can help you with that too? Let me show you. I've got my Dart and Flutter MCP server ready, so let's ask something like, help me implement a checkout experience that uses Apple Pay and Google Pay. The agent identifies the official pay package, and as you can see here, it's using the MCP server to securely interact with external data sources. In this case, the MCP server enables our agent to search pub.dev in real time, fetch the latest package documentation, and analyze the current workspace. This makes a big difference because including more context helps the agent write correct code. If we look at the results, the agent also wrote in the code to support Apple Pay and Google Pay in our checkout experience. Of course, if we don't like what the agent chose for us, we can reject the change and provide it with more context. Because the MCP server searched the package docs, the code correctly uses the latest API version rather than relying on training data. Here's what the checkout experience looks like on Android and iOS.
The new checkout experience is working great, but now we need to make sure it keeps working reliably. It's a good idea to add automated tests so we can know when something breaks. No matter how much we don't want to do it, our seventh technique is to write tests.
We've already eaten our vegetables and designed our app using good architecture patterns, so it's going to be much easier to add tests. First, let's add a unit test. Unit tests can validate the behavior of Dart code very quickly in parallel. They're great for testing individual classes or functions with different inputs to make sure they work correctly in isolation. Let's take a look at the cart view model to see how we can write a test for it. I can see that it takes a dependency as a parameter, so we'll want to mock that. And we'll use the new checks package like this. You might currently be using the matcher package to write test expectations like equals or is greater than. With the checks package, everything is strongly typed, so your IDE knows which checks are valid for the data type you're testing. We also have an agent skill to help you migrate from the matcher package to the checks package. Widget tests are great for testing, you guessed it, Flutter widgets. They also run quickly because they run without a physical device or an emulator, and can tap on widgets, verify the text that's on screen, and a lot more. Here's what the widget test for our button looks like. We can verify that it shows the correct values when we tap. Finally, let's use an integration test to verify that this feature works correctly on a physical device. Integration tests actually use the same API as widget tests, so you don't have to learn a new testing framework. And thanks to our MCP server, our coding agent can help with this too. Let me show you how that works. We've created this Flutter integration testing skill to help write integration tests. First, it enables Flutter driver, which enables the agent to interact with our app. From there, it runs the app and interacts with it to go through the user journey that we're testing on a real device. Finally, it captures those steps into an integration test that we can reliably run. Now our integration tests can be maintained alongside the rest of our test suite.
So let's recap. We covered 7 techniques for writing really good Flutter code. Design for constraints, not fixed sizes. Debug using DevTools. Build reusable widgets. Bake a layer cake. Use the repository pattern. Design for all platforms. And write good tests. Whether you're writing out code by hand or iterating with your coding agent, we hope this helps you write Flutter code that is more readable, scalable, testable, and faster than ever. To learn more about Flutter's best practices and all of our developer tools, Point your browser to flutter.dev.